It is said to be one of the biggest model train innovations ever. In 1946, when Lionel restarted train production after World War II, the feature of simulated smoke was introduced to the 3-rail O-gauge model train world. Over 50 years later, it's the selling point and beloved feature of many of us modelers. It's become a standard feature not only for the stacks of our locomotives, but even the whistles and various release valves throughout a steam locomotive. With the introduction and rapid growth of Blunami DCC in the industry, there's been a huge desire for instructions on how to implement the feature of smoke with this new technology. It's time for me to show you how to implement smoke with Blunami DCC. All that and more here on Sid's Trains. Would you like to save $10 off your next order of $50 or more with TRAINZ.com? Use my code SIDSTRAINZ at checkout and use my affiliates link www.trainz.com/SIDSTRAINZ. Your support is greatly appreciated. Hey guys, Sid from Sid's Trains here, and welcome back to the channel. I hope you're all having a great day. It's been over a year since I made a video showing you how to install Blunami DCC into your 3-rail model trains. And the most common question has been how to do smoke with Blunami. So today I'm going to show you how to do that. Linked down in the description are various diagrams, components, and other information that I talk about throughout the video. So use that accordingly. And also feel free to pause the video so that you can understand what I'm talking about. But let's get right into me showing you how to install smoke and make it work with Blunami DCC. So for anyone who does not know, Blunami is a Bluetooth-based digital command control system, DCC, that was introduced a couple of years ago. DCC is not traditionally used in 3-rail due to our AC sine wave powered trains. But Blunami being Bluetooth controlled makes it perfect for us. No need for DCC power in our tracks. So with some basic components to convert AC track power to DC, we are able to implement it in our trains now. If you would like to know more about Blunami and how to install it, check out one of my previous videos. I'd also recommend checking out my friend Johnny at the Optimus YouTube channel. He has videos going over the Blunami basics and the user interface experience. All the links are in the description below. Before we get started, I'd like to note a few things. Please be careful when working with electronics and soldering irons. Take all the necessary safety precautions when doing any kind of work that you see in this video. Additionally, installing smoke with Blunami is best done with a fan-driven smoke unit. It's not 100% required, but this video is aimed towards fan-driven smoke units, so just be aware. Also note that syncing the puffing of the fan to the chuffing of a steam locomotive is not possible with Blunami. Finally, throughout the video, I will be showing diagrams and test fixtures of these circuits to more easily demonstrate the concepts for you. Similar to lighting effects with Blunami, implementing smoke is done by using a function output on the Blunami decoder to control the smoke. But do not directly connect a smoke unit to the decoder. That will damage the decoder, and the only smoke you will get is from the board. That is not what you want. Instead, there are some basic components you will need to implement smoke effectively with a Blunami decoder. The first and most crucial component is a relay, preferably a solid-state relay. What this does is prevents the decoder from having the current load of the smoke unit running through the function output. It can't handle that amount of amperage. Instead, the relay, which has a low current draw, is turned on and off by the function output, and the smoke unit is kicked on and off by the relay. If you are interested in the relay that I use, the link is in the description below. In general, I'd advise using a relay that can handle around 1 to 2 amps of current load and 25 plus volts through it. Also make sure to take note of the voltage required to trigger that relay. Now that you have a relay, it needs to be wired so that the decoder can activate it. A solid-state relay has 2 sides to it. One side is the trigger side, and the other side is the side that acts as a switch. The trigger side of a solid-state relay is similar to an LED diode. It has an anode and a cathode. The anode is the positive, and the cathode is the negative. It is also similar to an LED diode or a light bulb that we would use for lighting in that it requires a lower voltage than the decoder outputs. So we must install a resistor in line like I did with the LEDs for the lighting effects. The relay that I am using requires around 1.2 volts, so a 1000 ohm dropping resistor will do the trick. Make sure to check the datasheet of your relay for your specific application. Once you have the relay and dropping resistor, now you can solder them together and attach the wires so that you can have a setup that looks like this schematic. I attach the resistor in line with the anode of the relay, and then add wires to run back to the decoder. The positive wire goes to the V++ on the decoder, while the negative wire goes to any function output connection of your choice, F3 through F8. That is the trigger side of the relay setup complete. Now when you turn the function output on and off, you are completing the circuit like a switch on the other side of the relay. Here you can see my multimeter showing continuity across the switch side of the relay when it is turned on. There are a wide variety of smoke units out there, but in the world of fan-driven, there are two main types. An all-in-one that drives the fan together with the heating element, or units that require an additional power supply for the smoke fan. Something like an MTH Protosound 1 unit, a K-Line fan-driven unit, an early Lionel fan-driven unit, or a third rail / Train America Studio style fan-driven smoke unit have the circuit attached to them that drives the fan. So this is that kind of all-in-one where you just apply power to it and then the smoke unit turns on with the fan and the element. In addition to the relay setup, the only component needed for these smoke units is a roughly 12 volt power supply. Note that some units differ, so adjust your voltage accordingly. The 12 volts can be achieved using a mini DC to DC buck converter. It takes the DC power from a bridge rectifier setup like we use for the decoder and drops it down to a user-determined voltage based on a little knob on the device. In this case, 12 volts. The smoke unit's positive and negative terminals are connected directly to the 12 volt output positive and negative connection on the buck converter. The way that you ensure that this is switched on and off by the relay is by running the positive DC voltage from the bridge rectifier through the relay and then to the input of the buck converter. The DC negative goes straight to the DC negative input of the buck converter. Once you've done this, your all-in-one smoke unit should now work with your decoder, switching on and off based on the function output. A unit that requires not only a power supply for the heating element, but has a fan that needs a power supply would be something like an MTH PS2/PS3 unit, or more recent Lionel Legacy smoke units. These have no power supply built in for the fans, so two mini buck converters will be needed. One to drive the heating element, and another to drive the fan. Heating elements on these units usually operate in the 6 to 12 volt range, so adjust yours to the voltage that gives you the desired smoke but doesn't overheat. The fans usually require 3 to 5 volts depending on the desired fan speed. The overall connection process is the same. The heating element and fan are connected to their own buck converter output connections. Meanwhile, the buck converters are switched on and off by running their positive input connection through the relay, like I said before. Once your connections look like this, you should be all set and have smoke. Every model is obviously different. Smoke units and other aspects may vary per your specific application, but these steps are the general way to get smoke control with Blunami. Get creative. I know I have. Using the techniques in this video, I've been able to add whistles theme and even animated effects like swinging bell to my Blunami equipped models. The sky's the limit. Many have asked for a Blunami coupler control video, but others have come up with solutions for that. I put some links in the description about Blunami couplers if you're interested. That's going to do it for this video. I hope you all have enjoyed. Let me know down in the comments below what you think and if you have any questions. But as always, like, subscribe, and click that bell for notifications. I'm Sid, and I'll see you next time.